This
1 minute.
conference will now be recorded.
Okay, so long story short here, we'll get back to it. The occupancy sensing is critical. There's nobody pulling orders or doing anything in a particular area, then that obviously we can save a lot of energy by dimming in that area. We can also do the high-end trim, which Rich mentioned, where as a matter of standard, we might set the trim at 80% so that customers will save 20% right off the bat. And if they want to, they can do scheduling. Now, we talked that this particular webinar is kind of rudimentary, but it's really necessary as a building block for the next two, which will be a little bit more technical or a lot more technical. But in terms of scheduling, we will introduce a gateway, which we already have, and we'll start talking about that next week. So what are the control components that we'll need? Well, it's pretty obvious. We need the sensors itself that would be present on the high bay. Now, you see the controller here. This is, you don't use a sensor and a controller at the same time. They're mutually independent. But what's cool about this is that they do communicate. And there's a significant cost difference between the sensor itself and the controller. Okay, so quite significant. So instead of having a sensor on every luminaire in an aisle, you might have an actual sensor on the first fixture in the aisle and the last fixture in the aisle. And everyone in between would have, in this case, a PSCW CM50, which will be communicating and will be part of the mesh network. But it'll be taking the place of a sensor. So keep that in mind. And then, of course, we have the manual overrides with the switches that can do on-off or dimming. And then the other one here with the 4 buttons that you see, you can actually create scenes, and that'll be done later. We'll talk about that. But the main thing that I wanted to point out, especially for the people that may not, just not know that much about the controls piece at this point, is that you have sensors, but you also have these mesh controllers, which are operating in other fixtures, and this is a way to save money on the project. So we talked about different things. Here we have an example of presentation rooms, testing labs, storage, workrooms, and offices. And all of these can have a different control strategy. So let's talk about, now we move from the warehouse or industrial area into the offices. And there's a variety of different ways to go here. So the control strategies, again, are occupancy and vacancy setting. The vacancy is at what point, does the fixture dim down after a certain time delay where there's nothing detected. Of course, the dimming. Now, daylight harvesting. The important part here is that this is true daylight harvesting. So this would be continuous fluid dimming. So even in a particular office area, you may have 2 zones, okay? You have the zone by the windows where we want to control, we want to put the daylight harvesting sensors, and then you have the rest of the room that's reacting to that. So that's an important thing to understand. It's not just bi-level, it is fully continuous dimming. Of course, you have the manual override and the various control scenes. Now, these 2 that you see here, these would come basically through the ceiling. So you would see just the lens on this, and I can show you the data sheet afterward, but it shows how there's a lock nut on the back, and you would make a small hole or perforation in the ceiling tile, and then you could have this in the room. Okay, so in addition, we have a variety of other ways. You don't need to use those 2 sensors only. You can also use a motion sensor like we have here. This would work in a 360-degree direction and could be in the center of a room where you have that, and it is communicating once again with the modules that are resident in individual fixtures. So once again, you don't need to have a sensor on every fixture. You can have a central vacancy, an occupancy sensor in the room that is communicating with the rest of the material. We also have, I have a picture here of the WCM 100. So the WCM 50 is a single channel, as they call it. The WCM 100 is 2-channel. And the purpose for that is color tuning. So when we get to that point where we're offering color tuning devices, we can actually use these modules to tune the fixtures to the appropriate color. And so these are all the things that you can do. A lot of them are repetitive, but you can use different gear to get it done, and so on. Okay. We have even additional, more sophisticated controls. This particular one, the WCM 450, we were going to take it out, but we're going to leave it in for now, just for discussions. This one does all of the above, in addition to heat sensing. So it can communicate with the HVAC, and it can also do like heat mapping. So there's a lot of different things that can be done with this. And so we are going to evolve, if you will, into more sophisticated controls. Once again, pretty similar to the private office is, depending on what you want to do. This particular sensor does motion sensing only. Okay, so there may not be a reason to do daylight harvesting if there's no windows in the room or no skylights in the area. So, you don't need to have too much, whereas this particular item here will do both motion sensing and daylight harvesting. So you have a choice. Once again, we were talking about a private office. In this case, the only sensor in this strategy might be the wall switch. So as you can see, we have a wall switch here with the motion sensor. So this is a combination unit. Somebody walks into the room, it detects the person and actuates the controllers, which are resident in the fixtures. So in this scenario, there's nothing on a fixture or in the ceiling besides the actual controllers. And okay, let's talk about the stairwell and the bathroom. Okay, so these employ sometimes a different strategy using an ultrasonic sensor. And the reason for that is if you think about a stairwell, these work on sound, right? The ultrasonic sensor. So essentially, if somebody walks into a stairwell on floor number 1, and they're going to go up to the second floor, a PIR sensor or passive infrared won't see them on the first floor. However, the ultrasonic sensor will hear them and therefore will kick in the control strategy for the stairwell. So you might say, well, why the ultrasonic? Well, that's a really good example. The same thing with the bathroom where you have stalls. PIR can't see through a metal stall, for example. So in this case, the ultrasonic would be the preferred sensor. And of course, they would work with the various switches and controls. So keep that in mind as far as the application for stairwell and bathroom. Okay, so application guide for outdoor. Once again, we wanted to talk about the parking lot. And what is cool about this is that this particular sensor that I showed would not only work on a high bay, but it gets embedded into a site lighting fixture. Okay, so just like we would need for Title 24 or any other control strategy for the parking lot, you can have this. Now, if I can, maybe I can blow this up. There is an antenna right here, and that is what is going to be communicating with the other fixtures in the parking lot and on the mesh network. So essentially, this device by itself is not IP65, but it will be when it's put inside a fixture that's IP65. So, and the other thing about this product, and I think we talked a little bit about it, it's on the data sheet, is let's say that the area light in question does not have room, or for whatever reason you can't install this sensor in the fixture. You can have this in an IP65 rated box, which will mount to the pole. So in this case, you can still employ the strategy. Now, once again, do you need to have a sensor on every fixture or every wall pack? The answer is no, because once the mesh network is programmed, you can introduce these controllers, and they can communicate from fixture to fixture, from wall pack to wall pack. And so this sensor is used mainly in high bays, but also in outdoor. Now, I mentioned also the gateway, which we'll be introducing next week. Gateway, remote user, you'll need internet access, but a remote user can control the situation. They can set up scenes. They can data mine. They can look and see if any fixtures are out. So the gateway will be a critical component, particularly for larger campuses where let's say you have an energy manager or somebody who's monitoring the entire project or wants to make changes. They'll be able to do that by way of the gateway. And that gateway, as I mentioned, will have to have internet access, but it's great stuff. So let's just take a quick look at some of the things that True Blue projects that have been done. There's a variety of different things. Go real quick. The first one is this Yamaha Motors distribution center. As you can see, this is a combination storage facility. They had over 25 zones and over 400 devices that were being controlled. And the strategies they employed were motion sensing, bi-level, and manual control. And simply using the high bay motion sensor and a switch. So you can, scale this up from an office to a major project. So another one was a manufacturing facility that they did using the True Blue mesh network. This was a larger facility in Georgia, over 150,000 square feet. It was a 24/7 facility for water bottling operations, and they employed over 585 control nodes with a variety of different strategies, including motion sensing, daylight harvesting, bi-level, and continuous dimming, which, as I mentioned, is important because sometimes bi-level dimming is not preferred. You need continuous dimming. And in terms of the hardware, it was pretty much the same hardware, the high bay motion sensors, daylight harvesting, etc. Now, this is probably the biggest project that's ever been done with the True Blue Mesh Network. This was in Minnesota, and this was an office building. I think, 22 stories. It was done over 470,000 square feet. It had a variety of tenants that were resident in the building on 22 floors, 43 separate areas with over 708 zones, 4,000 devices. And this is the largest Bluetooth project to date, at least at the time. SIG stands for the interest group, the special interest group that oversees the Bluetooth licensing, et cetera. And so the control strategies were motion sensing, vacancy sensing, daylight harvesting. You can see windows there, continuous dimming, high-end trim, and they used the variety of controls to get this done. But the interesting thing here is that even though they weren't going to use it right away, the owner of the building employed 30 gateways for future IoT expansion. And they were installed in a variety of locations so that they could later on expand the network, monitor energy, space utilization, heat mapping, which tells you, where people are congregating and if a particular room is being used or not used, and actually communicating on the back net with the HVAC control. So as you can see, this can get pretty complicated. And so these are just some of the ones that did. Now, the last one I want to mention in terms of the strategy here was the MidAtlantic Regional Business Park. This was a huge facility, 133 acres, with 600,000 feet of workspaces. But in terms of the outdoor, it was 10 plus parking lots, and there was a 2-mile long ring road that's circled the facility. It was a combination of gateway scheduling, photo cell, motion sensor, and bi-level dimming. So this was all undertaken for a huge outdoor project. So really want you to understand that we have a tiger by the tail here. It can do a very small thing like a storage office, or it can do a gigantic campus, okay? So I'm gonna go ahead and finish. That's the end of the PowerPoint for those of you that have been PowerPointed to death. I just wanted to do a couple quick housekeeping things. Number one, don't forget we have a controls landing page. And so we are adding new products to this every day. By the time we meet next week, the gateway will be on here, along with a couple of other components. So this will grow. What I also wanted you to do was look at some of these spec sheets, get a look at them, understand that most of them are low voltage, so they require power. They require low voltage power. So in many cases, you're going to be utilizing a low voltage power pack, which will take high voltage and convert it to low voltage to power the various sensors. The one that does not require a power pack that works on AC voltage is this BSC-BL IFM. It works solely on high voltage and converts. It has its own transformer, and we don't. This would be great for high bays and mounted fixtures, linear fixtures, strips, wraps, all that. It doesn't require any kind of low voltage. But this is all for you to look at your convenience. And finally, in advance of next week, I would invite you to, I'm going to send out this link, to go on to the trueblue.mcwong.net website and register yourself, okay? Sign up, get yourself an account, and you can start to play around. You can't do any damage. Play around, create your own projects. And so this is easy to do. And also, you might want to take your cell phone, and if you can see what I'm doing here with my cell phone, I've installed the TrueBlue iOS app onto my phone. And you could do that as well. Now, one thing, and the last thing I want to mention for right now, is that when it comes to the commissioning process, you will need an iOS device. That would be either an iPhone or preferably an iPad. So the commissioning at this point is contingent on an iOS device. That's not the case for the software on your computer to do that. But I'm going to go ahead and that's pretty much what we have for today. Rich, did you have any other additional comments?
The only other comment I would say is that we will have the ability to do the commissioning not only on iOS, but also from other platforms. I believe the time frame is going to be around November. So there's more coming.
Great, great. Well, thanks again for everybody. For some of you, it may have been, pretty simple. Just, basic review. For other people, it might be kind of the first dive into controls. So, but next week, we're going to get into project planning, and then followed by the commissioning. It'll be a little bit more technical. And like I said, I invite you to, go on to TrueBlue and set up an account, and we'll be in touch. So next one, a week from today, and that'll be project planning. So if there's nothing else, I'll go ahead and end it here. Thanking everybody for their time, and have a great day.
Thanks, Dave.
All right.